Okay.
Cool.
There you go.
Hi everyone.
Sounds good?
Can you hear me? Okay.
Okay.
So today I will speak for something we are working last 6 months, and this is how to implement open source hardware for smart cities. My name is Svetan Uzunov. I'm owner of Polymax. Polymax is a small company in Bulgaria. We do electronic design, some different productions, and all products are designed and manufactured in Bulgaria. I have to say this because often people ask us, do you produce in China? I think this is a compliment. So it means we are so efficient that people cannot believe it can be produced outside China. But we do produce in Bulgaria. And we have some Linux computers, IoT solutions, and many of our products are with open source license. And this doesn't make problems to our business at all. So what is smart city? A lot of people have different concepts for smart city, but what I think is the definition which is more proper is this is city where do you have a lot of sensors which measure different kind of things and then send them by network to some remote computer, and then you can make different applications which to collect this sensor data, to process it somehow, and to make some kind of interaction with the other infrastructure, so-called smart solutions. And here I just list just few of the possible applications which can be done. First, all the utility metering like electricity, gas, water, they first use the IoT and these concepts with the many sensors and collection the data. Another very interesting project is the park management. Just imagine you go to some unknown city and you are looking for parking spot. The locals know where to park, but you are in a foreign city, and if, for instance, every parking spot has sensor which sense if there is a car above the sensor or not, it can report this information to a server, and you can make a small app on your telephone. You open the map, it sends your GPS coordinates and see on the map where is closest free parking spots. It will be useful. You will not make circles to try to find some free spot. You just go there when you know that this parking spot is empty. Environmental monitoring is another field where the IoT and smart city solutions can be done. You can measure the temperature, humidity, air pressure, CO2, a lot of different things, including if there is water flooding or fires, for instance, even not in the city, but in the mountains, in the woods. The waste management is where a lot of savings can be done, because what they do now is every week a car pass by and collect the waste bins. But what if they are not full? Why should they go? Or what if these waste bins are full earlier than 1 week? So a lot of optimization can be done, and this to save the taxpayers' money. Street lighting is the same. For the moment, there is no automation in most of the city. They just start the lighting on given hour and off the lighting at another given hour. But what happens if nobody is on the streets? Why they have to light on all the time? Or what happens if some light bulbs are for replacement? It's not possible people to come around to all the streets and look if this work or not. Just in Plovdiv we have 80,000 street lamps. 80,000. Public transport monitoring is another subject where this sensor technology can work pretty well. or traffic monitoring and information display, which to tell you there is a jam, traffic jam on this and this street, take left or take right. So we see that to implement this smart solution, we need networking. And one of the traditional networking is Wi-Fi. We already know that it's easy to install, it's low cost, allow fast data transfers, and you don't have to pay for this data transfer. But obviously, it's short range, it's not low power, and it has some pairing latency. Bluetooth Low Energy is almost the same like Wi-Fi, but we have a little bit lower power, and the trade-off is that the speed of the data transfer is not as fast as with the Wi-Fi. Another traditional networking is cable. This is what mostly in our city is used, but it requires a lot of infrastructure changes. You have to dig, to lay out cables, and not everywhere you can dig without permission, so you have to get approval, which might take months, and this is not the best solution for this. And just imagine if you want to employ thousands of such sensors, what will happen with how many cables and we have to put. So there is a very interesting technology called LPWAN, which means low power wide area networking. And one of the most popular is LoRa. If you go to any electronic show this year, you will see on every booth, everybody is offering LoRa solutions. It's like, you must have it, or you are not up to the latest technologies. Why is LoRa so popular? First, it is wireless, so it's very easy to install. You don't have to dig holes, you don't have to cables, you just put it and it works. Second, it works on license-free frequency, so it costs you nothing to employ LoRa technology. LoRa is already mature technology. It's not new, and the prices are already enough low to be attractive for many applications which were not available before. And it's low power. If you put a LoRa sensor somewhere, it can work up to 10 years without touching it. Even for these parking sensors, they don't install them. They just dig holes, put the sensor, and put asphalt on it. Because after 10 years, they will have to repair the street anyway. So it's trouble-free. You put it and forget it, and you have communication with the sensor for years. It's incredible. And you don't have to pay taxes for the data transfer because it doesn't pass through a GSM operator. You don't have to put SIM cards, and etc. So this is what makes LoRa technology really very popular, and a lot of people start to use it. Of course, it's not perfect. The data speed is very slow, but it is intended to read sensors. You don't have so many information which you have to transfer anyway. Some more details. It works on the license-free bandwidths at 33, 868, and 915. It's a different 868 is in Europe, 915 is US, and 433 is everywhere. But I don't advise you to use 433 because all the key fobs for cars, for remote controllers work on this operation, and it's a lot of noise on these frequencies. It operates on very narrow bandwidth, 125 up to 500 kilohertz. This is one of the features which allow LoRa to talk at so long range. Actually, LoRa means long range. It's made of this. And the narrower your band is, the higher sensitivity of your receiver is, because they look for the signal in very narrow band. And this way, a receiver which works with one sensitivity, if you use wider band, on a narrow band, you immediately receive a better sensitivity, which extends your range of the transmission. The payload is small, as we said. It's from couple of bytes up to 51 bytes if you use the longest distance configuration, or up to 225 if you use the higher speed configuration. The data rate is from almost 300 bits per second up to 5050. What is also great is that you have encryption. So nobody except the one who has your private key can understand what this payload is. And the distance is up to 5 kilometers if you follow the European norms and don't emit more than 14 milliwatts power. And it allows up to 5 kilometers when there is clear air. Or in the urban area, it depends. It's between 1 and 2 kilometers. If you have many buildings with a lot of metal inside them, it will be shorter. If you have less obstacle, it will be up to 2 kilometers. Of course, this is very dependent on what antenna do you have. Here is one more graphic which show what is the distance depending on the different spread factor, bandwidth, and bitrate. As you can see, the longer the distance becomes, we have better receiver sensitivity, but it works at lower speed with narrow band and with wider spread factor. The spread factor is LoRa technology is made with chirp. Yes, technology which is used in the space and military for many years, and it's very hard to jam because it sends the signal on many different frequencies, and it's impossible to jam the signal in the whole bandwidth. So if we want to receive the maximum distance, we have to make spread factor SF12, the bandwidth as low as narrow as possible, and if we have a payload of 51 watts, it will require time on air about 2.4 seconds to send these 50 bytes. It's very slow. But this allows us to make work on batteries for very long time. For instance, this transceiver, which is LoRa transceiver SX1276, it has about 30 milliamps when it transmits. And let's say you have a budget of 10 milliamps for the surrounding circuits, like microcontroller, which will implement the protocol. And if we use lithium battery, 3-volt lithium battery, which is standard AA type, with 2.7 ampere hours, we have 9.72 milliampere seconds. And when we divide for them by 2.4 seconds, 40 milliamps, we receive about 100K messages before we drain the battery. And if, for instance, we put budget 10 years, we can transmit up to 27 messages every day. We will not drain the battery for 10 years. So the calculation is correct. Now, LoRa limitations. What we have like advantage, the long range is actually also disadvantage of LoRa. Why? Because when you have a receiver which receives in the 2-kilometer area, if you put a lot of sensors there, let's see, if you put more than 2,000 sensors in this this range of the transmitter, they almost cannot connect to the gateway because everybody attempts to talk and jumps with somebody else who also wants to talk. So this is one of the problems with LoRa. in Plovdiv, we don't have this problem, but in Sofia, there are a lot of people who try to implement LoRa solution, and you know, they work on the license-free frequency, but license-free, this doesn't mean that this frequency is yours. If you want to follow the standard, you should not talk more than 1% of the time. Nobody comply with this. They just talk until the gateway confirm that received the message. And they make impossible for other people to follow this standard. So I had customers which come last week and they say, show me where this LoRa works, because we tried in Sofia and it doesn't work. And I say, yeah, here in Plovdiv still works because there are not so many users which do not follow the standard and just emitting on the maximum possible distance, the longest messages they can do, and don't care about the others. So, this is one other very interesting technology, which is similar to LoRa, but it has not free traffic. NB-IoT was developed by Huawei, Qualcomm, and Ericsson. And it's the same committee, 3GPP, which make the LTE standards. And you know, they say it's LTE 3G, 4G, 5G. This is 0G. Because it's very simple. It's lightweight protocol. Normal LTE protocol works on 5 megahertz bandwidth and can achieve a lot of megabits of transfer. Here, they talk to 200 kilohertz bandwidth. What happens? The sensitivity of the receiver allows bigger distances. And even at small speed for the LTE, they work with 30 kilobits. It's still 100 times faster than LoRa, and it allows a low time on the air. So it is low cost, low power, and long range. The problem is you need SIM card here. One good news is that there is a competition. You can buy online card from UK, which costs $1 per year and $1 per megabyte. The problem is that not every local operator will allow roaming for these cards. So, one of the most popular is one model of QuickTel. Why is popular? Because it covers every single frequency which you can use in the world. So you put one module and forget. You can use it in Asia, you can use it in Europe, in Africa. If you see the other competitive modules from Simcom or other, they keep, one is for Asia, one is for Africa, and if you have to move this equipment, it doesn't work. Here you buy this module and you can scale your production and send devices to any customers everywhere in the world, and these modules will work. Another very interesting thing you have to check in the datasheet is the operating voltage. All the lithium battery capacity is for discharge from 3 volts to 2 volts. So this capacity which is written on the battery means the battery, when it's fresh, will show 3 volts, and when it starts to discharge, it will become 2 volts, and then it's 0. Some modules work up to 2.75 volts, which means, yeah, you will use just 10% of the battery capacity, and you can make some calculation and then see, wow, this module stopped working after 2 months, not 10 years. So it's very important to read the datasheet when you select your modules. Bonus, you have inside Cortex M4 working on 78 megahertz with 400K flash, 400K RAM, and programmable by Arduino. Can you imagine? The data rate, as I said, is uplink 30 kilobits, downlink 30 kilobits, and the distance is 20 decibels more than GSM. This means 3 times more distance. Onecell can talk to nodes up to 100 kilometers if you have free air. And Onecell can handle 100K connection, which is incredible. And this is 30 times more than LoRa capacity.
Sure about the model number?
Yes, BC66.
Because there's also BC96.
96 is a different story. It's LTM. This is LTNB. Yeah. And this is very low cost. I have been, November, Quicktel has a workshop in Sofia, and they show me the company data, and they said, we are selling 32 million modules, and our turnover is 250 million. Yes, say, oh, this is good, $7 per module. And ask them, they confirmed, yes, this is the price for volume. It can go even lower. And when you think that you have inside Cortex-M3, which maybe costs a couple of dollars, it's really, really good price for the module. So, why should we do open source hardware for the smart cities? Because once it's done, it's easy to replicate. We can do this for Plovdiv, and then another city wants to use the same application. They have completely project documentation. They can replicate it very easily. Then, easy for maintenance. When I spoke with some people in the Plovdiv municipality, they are very, very careful, because they say, somebody comes here, makes something, then decide to go away or to ask more money, and it doesn't give any documentation. So we left with something which is not useful. Next, who come here and say, I cannot use this, I will offer you my new solution, but you have to pay again for it. So you have replication, you have maintenance. Also, you share expertise, because what I learned is that in the municipality, they are not technical guys. They have no expertise. They are very difficult to understand which works and which doesn't work. And they always are surrounded by some lobby people from big companies which try to sell them something, and they don't know if this will work or this will not work. For instance, in Plovdiv, they made a public transport managing system for 30 million euro, and it doesn't work. And I asked him, how did you pay this amount of money? They show us cities when they implemented this. And then after few months, this system stopped working. And they don't have the logins, they don't have anything for the system, so you have to pay more money to make it working, something which they already paid for. Then, easy customization. If some other city want to change something, they are able just to adopt this solution and to change it, or to collaborate and to send feedback. Okay, I had a lot of things to say, but anyway,
Yeah, a couple of minutes.
questions? Couple of minutes. Okay, so I can get very. So we have some Wi-Fi solutions, which is Wi-Fi Bluetooth low energy solution, and here you can see later on the. We have computers which are suitable for servers. Here I list all the features which are positive and negative for this. Then we have a LoRa open source hardware solution, which starts from the transmitter for €5. Then you have a transmitter with a UX connector, which connects directly to Arduino or to ESP32. And you can make small gateways. You have a big gateway, which works up to the Things network. Then we have a different antennas. As you can see, we have from big 1 meter antenna to small few centimeter antenna. And what this means, 6 dBi, this is relatively output power compared to the isotropic source. What this means, if it's 6 dBi, this means that this antenna with the same transmitter will increase your range 2 times. And for instance, for 3 dBi, it will be half time, 40. So if you have PCB antenna, it's about 0 dBi. So when you select your solution, for a gateway, always use good antenna because it will just double your range of communication. So the summary is that smart city concept can have a lot of benefits from open source. And it will be easier to collect. Also, the open source hardware always lead to fair prices because everybody see your BOM. If your BOM is $10, you cannot sell this for $200. So that's it, basically.
Let's take a couple of questions while Andre prepares. Questions? Yes, here?
Just shout it, is it?
Yes, and he repeats it for the recording.
Do you find with the open source hardware that more people are attracted to your solution? Do you know, because you're not vendor locked.
Yeah. So the question was, do we get more people attracted because the solution is open source hardware? Definitely. We have customers which selected our boards just because we are open source hardware. And I'm talking for big companies which has a lot of business on stake, and they have to be secure for their business. If they use some closed source hardware, once this manufacturer or vendor stops selling this, they are gone. And when they work with the open source hardware, they always know that even if I'm not interested to do this, they can find somebody else to replace me. So this gives security for their business. Even if everything is equal, my product looks more appealing to them because it has more value for them.
Any other question? There's one here. Yes? Yep. One question.
Yes.
Can you say why LoRa instead of Zigbee, for example?
Because
Repeat question.
why LoRa instead of Zigbee? Because LoRa is longer range than Zigbee. It has Zigbee cannot work 10 years on battery, especially if you have mesh network with many devices which start talking between each other. Zigbee is nothing less different than BLE. It's like Bluetooth low energy.
Does the battery last 10 years for you to be able to claim that the device will last 10 years on a battery?
In the best speculation, it might.
Yeah, because the battery is the most important part to last 10 years.
Depends on if you send only or if you receive. If you receive, you need a lot of time.
Yeah. No, there is a protocol which tells you the sensor tells to the gateway the value, and gateway say, okay, I will call you after a few days. So it's.
Very nice. Okay. Thank you, Zvetan.